quite a hazy look to the sky this afternoon. Looks like we're getting a bit of that dust because it's got kind of a light beige tinge to it. And that is one thing that always clues me in when it's got that whitish, milky color. Then I suspect dust. And we look at the METAR plots. Not really any evidence of that in our area. Visibilities are actually pretty good at a lot of sites. But once you go down to the Gulf, we do pick up this region of 4 to 5 miles in haze. Now, of course, the sensors can't really differentiate haze from dust, but we can go to the polar orbiters. This is the shot for yesterday. Now, if we look out in the Gulf, it doesn't look like anything obvious, but if we go to the aerosol optical depth, yeah, there probably is a little bit of dust still lurking out there in the western Gulf, and chances are that it vected northward overnight. So that's what's happening as far as Texas. Let's check out the rest of the U.S. Our weather map for this afternoon shows that front up in the Dakotas and Montana appears to have receded a little bit. And that's probably due to some advection of very warm tropical air on the high plains. Continued warm in the southwestern U.S., and you can see the heat low in an associated trough extending from about Lake Havasu City up through Tonopah and Reno. In Texas, continued warm with very moist air, dew points up near 77, even 78 there at DFW. And the dry line, it's still out there in the Texas Panhandle and West Texas. I would expect a few storms to go up along that this afternoon. Stationary front hanging around the Carolinas, extending into Georgia. That's going to be a nucleus for thunderstorm formation. And it is warming up in the northeastern U.S., even though we have northerly flow from Ontario. Ontario has been very warm the past week, so not much relief there. And then just a quick look up in Canada, since they've been kind of dominant with our weather over the past few months. High pressure up to the north. Big Arctic high. Well, actually, that's a kind of a weak polar high, pretty much. Temperatures in the 60s, so that's pretty mild, maybe slightly warm for this time of year. And then we've got this occlusion over Alberta that's been in place for a few days now. Labrador and Quebec, they've definitely seen some relief from the heat. Temperatures have fallen about 30 degrees in that region. Now, yesterday we focused on the North American weather pattern and looked at the upper troposphere. Today we're going to look at the mid-troposphere and check out the 500 millibar pattern. This is up at about 3 kilometers or 18,000 feet. So this is the mid-levels of the troposphere. And this is a good place to find short waves and embedded geostrophic disturbances moving through the flow. So what do we have here? This is heights and vorticity. The heights are in black lines, and the vorticity is in shades of orange and gray. The gray shades are negative vorticity, so that's where the flow has kind of a anticyclonic or counterclockwise characteristic to it. And the blue and red right in here, that's cyclonic or clockwise flow. So the flow tends to rotate. And that can be due to a combination of curvature of the flow. That's obviously cyclonic curvature. And it can be due to shear, like what's happening here in Montana. In fact, this whole axis of strong vorticity, you see how that's elongated with the flow? We refer to that as a channeled vorticity lobe, and that can indicate where a jet stream axis is. And that's going to be found on the equatorward side of that positive vorticity. So we're going to put it pretty much right in there. And you can see that's bounded by positive vorticity on one side and negative vorticity, the gray, on the other side. Fits right in there, just kind of like a channel. So whenever you see the vorticity elongated with the height contours that should clue you in that there's a jet stream running through that channel. So if we were to go to the 500 millibar winds, we would find it pretty much from northern Nevada across Yellowstone and up to northeastern Montana. Let's take a look at the 500 millibar winds and see what we really have. So this is 12Z, this is the 0Z analysis. And we assumed it was going to be right in here, and you can see the speed isotax, which are shades of purple and blue. That fits right in. So let's go back to that vorticity chart one more time. So we've identified the jet stream axis. Now there is another form, which is vorticity lobes, and these cross the height contours. Another example is right there and right there. So when it's crossing the contours, that tells you that there is vorticity advection taking place. Now with channels, yeah, there is some vorticity advection, mostly in the area out ahead of the channel. You can see like right in the middle, you're not really advecting in any higher values, maybe some slight differences. But the differences across these lobes are very strong. So that's going to be associated with very rapid changes in the vertical motion field. Now there are some assumptions with that. The actual vertical velocity depends on whether vorticity is increasing with height and what the thermal advection is underneath, but we're going to pretty much assume, and it's most of the time kind of a fairly safe assumption, that ahead of a strong vorticity lobe where you have vorticity advection, you should get strong upward motion. So let me give you a good example right here. Now it's kind of mottled, so you don't really see it too well, but yeah, that's a major shortwave right there, and out ahead of it, there's likely going to be weaker values. So as that approaches, we're going to have higher and higher vorticity values coming in. So we can assume that there is decent upward motion out ahead of that. And behind it, we should find sinking motion or subsidence. Now, do we have that? Let's take a look at a skew-t over Pennsylvania. And we would be looking for a mid-level region of subsidence, and that's it right there. That's a subsidence inversion. So you can kind of see these features on the charts as you go through them. And out ahead of these lobes, actually we'll just go right ahead of this channel since we don't have any really sharply defined vorticity lobes. I'm going to go out ahead of it, and this should be an area of destabilization. You can see there's not any subsidence inversion. In fact, there's steepening lapse rates, very steep lapse rates. It's almost dry adiabatic. So that tells you there's good vertical motion, and you can see that in the... I'm sorry, I should move this over to the right. Let me do that. Yeah, if you look over to the left here, that's the omega field vertical motion, and you can see that the vorticity, or the vertical motion, I mean, is assumed to be strongly upward through that layer. Okay, we're going to go ahead and go right into the forecast, so let's go ahead and do that. And we'll use the 500 millibar chart to kind of guide what's happening. So going forward into tonight, well, let's kind of describe the flow instead of just looking at the waves. What we see here, very strong ridge, upper level ridge right there. So that's going to be an area of fair weather. You can see the strong weather systems, jet streams, they tend to go around that. So this is an area of weak shear, a warm column of air, lots of heating, but it tends to be fairly stable most of the time. Not always, but usually does. And that's going to correspond to some of your warmest air, because the great volume of that weakly dense air, that warm air, is going to really bump those height surfaces upward. So let's go forward into tonight, into tomorrow. You can see that the subtropical high is centered over New Mexico, so they're probably getting some very hot weather there in Roswell and Carlsbad. Going forward into the 4th, there's Saturday morning. Definitely looks like a fair day all the way through the central and southern plains. The weather's going to be kind of unsettled in New England. You can see that little shortwave moving through the flow. Probably some afternoon thunderstorms likely there in the southeastern U.S. and probably some unsettled weather in the northwest. And then just running that forward, it looks like early next week, a couple waves moving across the northern plains. Looks like another one coming in to the Pacific Northwest. I see some evidence of maybe an upper level low, kind of a weak, maybe like tropical depression type thing. Tropical disturbance over Louisiana. And it looks like that probably drifts around and increases the chance of precip down in that area. So that's pretty much breaking down the strong subtropical ridge, which has kind of receded into New Mexico and Arizona. Looks like another weak upper level low over Kansas. That could be due to a convective cluster, but we shall see. Anyway, going forward into next week, very stagnant pattern. Looks like the only people getting weather are the Northwest and Minnesota, Western Great Lakes. And then going to the end of next week, that subtropical high really settles in over New Mexico and Arizona there. Meanwhile, out in the southeastern U.S., there's that little tropical disturbance there. Looks like that drifts out to the Carolinas. So I would expect things to be kind of rainy, maybe a little bit of precip there in Georgia and South Carolina late next week. And I think that's probably a little more informative than looking at the thickness and isobars, because this time of year the patterns are very weak. They can be kind of indeterminate. And you can see as we go into next week, I mean, you can kind of pick out where some boundaries may exist. I don't know, maybe in there somewhere that could be a meso high. But overall, it's pretty much dominated by this strong southerly flow. The fronts are well up to the north. So a lot of times the upper level patterns, they tend to shape what kind of weather you have going on at the surface. So that brings us to our next feature, the Astronomy Calendar. A couple of interesting events on July 4th. Earth aphelion. It's going to be the farthest that the Earth is from the Sun during its annual orbit, and it'll be 3.3% farther away from the Sun than it is in January. So we're actually receiving a little less radiation this time of year than we do in the winter. Also, even more notably, a lunar eclipse on the evening of the 4th. That's at 4:31 Z, so that's going to be about midnight, just after midnight Eastern Time, about 11:31 Central Time. And whatever it is you're doing on July 4th, that'll probably give you a little bonus to cap off the night. And then further down the line for July 10th, Venus reaches its maximum illuminated extent. That's going to be during the morning. The Mogollon Rim. What is it, and where is it? The Mogollon Rim is located in east central Arizona, right about there. And that is pretty important because it divides the higher plateau region in the Four Corners area from the deep deserts of the southwest. And that's the reason that Phoenix and Tucson don't really get flooded with a lot of cold air during the winter. It does happen sometimes, but it is pretty rare. Another important aspect of the Mogollon Rim is it's a focus for monsoon storms. As the moisture flows northwest from Old Mexico and Texas and New Mexico, we tend to get some pretty heavy thunderstorms developing along the Mogollon Rim because they're so prominent and the orographics are quite strong. And sometimes those storms move out into the Phoenix area and kicks up some dust. And late July is a very important time of year where that tends to happen. So the Mogollon Rim, now you know where it is. It's going to be just south of Flagstaff, north of Phoenix, and north of Tucson. And that's about all I got for this evening. I appreciate you watching the webcast. Thank you to our new supporter, David Warnick. Welcome to the show. And we'll be back tomorrow for our Friday edition and give you a heads up what's going on the 4th of July and come back at you with some more geography. So, hope to see you then. Take care, y'all. Bye-bye.